biology. Let's have a chat with your neighbor. What words do you associate with that? What do you know about it? We'll go around the room. Any ideas? Maria? Molecular biology.
I forgot about the molecules that make up our living organisms. Like the most simplest units.
Great. Anybody wants to add any words?
We said some important elements in molecular biology were carbon, nitrogen, oxygen, nitrogen, phosphorus, sulfur.
Sulfur, yeah. Joe, what do you think when you hear the word molecular biology?
We talked about biology focusing on molecules.
Understandings for today. Can we go around and take one each?
Molecular biology explains living processes in terms of the chemical substances in whole.
So very much what you already said, the macromolecules that are involved in life. Right, Simon?
Carbon atoms can form four covalent bonds, allowing a diversity of zero compounds to exist.
Okay, so carbon seems to be that key inside all these elements that we're going to talk about today. So I already said the structures and the function of the macromolecules that are essential for life. We've mentioned carbohydrates, we've mentioned lipids, we've mentioned nucleic acids, and we mentioned the proteins, very basic building blocks. They appear in monomers, in polymers. They have different characteristic groups. So I'm going to give you a while to look at them. What are they? What do they look like? What characteristic groups do I have? What do I know about the structure? What are the subunits that you should be recognizing? So there's 4 groups. I'll chop you into 4 groups. Eric and Zaman, can you take the carbohydrates, nucleic acids, proteins, and lipids? Make a few notes while you're looking at it of those questions that are there, so you can share with the group after what you found out about them. So in the protein group, let the carb group start. It's the 4th column. On the board at the back, I've drawn a little table. The monomers, what did they roughly look like? Any structures that you associate with carbohydrates, and what does the polymer look like? If you can come and fill in that together, or one of you.
So just write the name of what the monomer is called.
Yeah, or a structure, or a unit. What have you found out?
Which is just a long chain of singular carbohydrates structure.
Yeah, so the structure they need to be found as like a single structure, that's just a chain of carbons, although people mostly recognize them as ring formations.
Yeah, so this example is what?
So this would be the ring formation, so
Of what?
glucose.
Of glucose.
Because a general way of recognizing carbohydrate is with the formula CnH2ON, where M could potentially be a different number.
Yes.
So glucose would be C6H12, which is a common one. But then you also get isomers, which, like fructose, for example, they have the same formula but a different structure.
Different structure.
Yes.
James, what can you tell us about the basic subunits?
Okay, so so the monomer of a protein is called an amino acid, and what happens is it's like this, and what we have over here is this group called the amine group, and this is called the R variable because that's what identifies the specific protein, as the different R variables show what kind of a protein it is. Then over here we have the carboxylic group, and that's what identifies a basic amino acid. And what happens with amino acids is that they go through condensation or condensation, and then when they condense, what happens is the O reacts with another amino acid. So if we put another amino acid, reacts with the H's on the other amino acid, and what we get is water.
So
And then
could you know what that bond is called?
it's called I don't know, what's that, sorry.
Remember? No.
Peptide bond.
Yeah.
Oh, sorry.
Polypeptides, forming multiple peptides in a row. How many amino acids are there
In
in life?
so in DNA, I guess, would be 46.
No, that's the chromosomes. There's 20 amino acids. Some are essential, so we have to eat them. Otherwise, but some are non-essential. The body can actually produce them based from the building blocks. Let me help you out a little bit. So we know we've got the pentose sugar, right? And then we have a phosphate group. And we have our base attached. So that's the nitrogenous base. So two of them look like a ring, and two of them look like a ring. See? With an extra ring attached. Yeah, so that's your basic building blocks, and you're going to build those up to your strands.
But one of the ones they do form is triglycerides, and it's made of glycerol and 3 other fatty acids. And a glycerol is a trihydric alcohol, which basically means that it contains 3 hydroxyl groups. And the function of triglycerides in the body is to store energy and provide energy.
So what we see here, this is that, sorry, I don't want to go with you. This is that glycerol backbone, right? And it had OH groups. And this is a fatty acid, so it has the COOH group, and it's bonded to it. So the variation that we get is in the fatty acids. They can be really long, they can be really short, they can be saturated, they can be unsaturated. So this one is fully saturated when they depict it like that. Okay. So we'll see what that looks like once we start drawing. Yes.
So is it this raw type of carbohydrate or not? Really?
Yes. Okay. Thank you. So we do have to go a little bit to chemistry today. It might not be your favorite subject, but we have to think about the valence electrons in carbon. So carbon was element number 12 on the periodic table, right? So how we look at carbon. Carbon is can easily make covalent bonds. And why is that again? Dig down. In the first orbital, in the first shell, it had 2 electrons. Right? It's that configuration there. In the second shell it has 4. Right? So the second orbital is 4 electrons that would love to make bonds with other things. It loves to attach, make a covalent bond and share electrons together. That's when we talk about carbon and we draw those 4 lines. Because it has the opportunity to take up 4 electrons. And then can form those complex molecules. You can attach to one another. So once it has carbon, we call it an organic compound. We'll come back to that a little bit later because not all organic compounds are only made in lab. You can actually make some in the laboratory as well. Just 1, 2. And then that's just one aspect in the body, one chemical reaction that happens over and over and over again in the body. While if we zoom out, and I'll put these ones on, you can see all the different processes and reactions that are taking place. So this is the metabolic pathway of life. Lots of chemistry in every corner. Chemistry all around us as well, but also inside. So there's a lot of reactions going around. You can see some is different metabolisms, lipid metabolisms using the fatty acid that we've just spoken about. So we simplify it with the fatty acids and the glycerol, but everything that happens. Bigger. So here's the fatty acid, and these are all the reactions in the body that have to take place before a fatty acid like that is formed or broken down. One, two. One's over there, two over there. We're going to show and draw. Okay, so you can use the blue paper that's on the desk. We're going to show and draw number one. Ready? On your marks. Okay, pens down. All pens down. Let's see what we've got. Okay, these are the different monomers that you need to learn to draw, but also need to recognize. So here's a pentose sugar, also known as ribose. Thinking about our RNA, our DNA, remember we drew the subunit on the board? Then what happens at this carbon is that sometimes the OH is up and the H is down, which we call get it right, an alpha. The alpha, the OH is down. This is the beta D glucose. Beta D glucose. Right? If these two groups swap around, so we get the H at the top and the OH at the bottom, we have an alpha D glucose. Okay. So I want you to come up with how you're going to memorize that an alpha, the OH is down, and in beta, the OH is up. Right, what's the best idea we've got? Nirvana.
Okay, so we say that alpha is alpha and beta. Other way around.
See how confusing already. So why is alpha down?
Because beta is better than
Beta is better, so it comes on top. I like that one. Anything else?
You said that only one can be the alpha, which is by the sole AH is on top.
Say that again?
There can only be one alpha, so
Yes.
only one hydrogen is on top.
Okay. Alright, good one. Organic or not is the question. Everything is organic, so we have to figure out the name of the molecule. If you think it's organic, you can stand up. If you think it's inorganic, you can stay down. H2O. What is it?
Can we just put our hand up?
You can, yep. You'd rather stick your hand up. H2O is not organic because there's no carbon. Right? What is it? First of all, Joel, what is it?
Sugar.
Sugar, glucose. Organic because it's got carbon in it. CO2. Carbon dioxide.
Actually,
Inorganic. Oxides don't count. Shame. The same groups that you had, number ones and number twos, we are going to have a look at some puzzles. I put all the basic units of a pentose or hexose, a lipid, a peptide or a nucleic acid on cards. So you're going to have to build them. And then once both sides are done, we'll swap over. So you get a chance to do all four. You've looked at them, you've drawn them. So it'll be fairly easy to build them now.
That's CFP, yeah. So that's what the, those are the, nucleic acid.
You really have to, but I'm sure by now you'll be fluent. Nobody here? Two there. Three. Four. Everybody just goes like
Oh, we now understand that it's
We're working in
Oh
people.
my god.
no, I think that's.
That's
Is that it?
No, that's
We're working in teams.
we enjoy.
We're not working.
working.
We're working in teams.
4, 5. Okay.
But hey, you can work.
Are you ready? 12 questions. Name the molecule.
There's no.
Lipid. Remember when we talked about the cell membrane? This is a typical example of a phospholipid. Oh, Eric, well done. In the lead. Last question.
No.
Tuna, you're
Get
gonna
this one wrong,
score
Joel.
up to the top.
Tunde is Joel. Alright, Tunde is just the voice.
This
that-
molecule is a. Go back to your previous unit. You know what it is.
2 seconds.
How did that happen? Right?
That just happened like that.
Yeah, you okay?
So for eternal fame is other. Well done.
And the top
We can
five.
do another one. Guys, well done. I will get you all the details that you have projected. I've also got your tests from the last unit. And I will send you the mark scheme with that as well.
What is this?
Tunde.
I already know my grades.
Oh no, no, no.
Wait, did you just wrap it up? I'm keeping it in a secure place.